Welcome to AI Podcast. Today we're digging into a fresh EMNLP 2025 paper called Improving Large Language Models Function Calling and Interpretability via Guided Structured Templates.
I saw that title and thought, okay, what's the headline? What should I remember if I only catch the first minute?
The headline is simple. Give your model a small, explicit checklist to follow before it makes a function call, and you get fewer tool use mistakes and clearer, auditable reasoning. It beats free-form chain of thought in most cases, and you can use it as a prompt or bake it in with fine-tuning.
A checklist, like a pilot's pre-flight routine?
Exactly. Think of it as a pre-flight for API calls. The template nudges the model to identify candidate functions, check relevance, skim the docs, extract the user's parameters, fix types if needed, draft the call, and then do a quick self-audit before sending anything.
Right, so why not just chain of thought? That's already step-by-step, isn't it?
It is, but it's freeform. Function calling is more like filling out a precise web form than writing an essay. With freeform reasoning, models wander, skip fields, or hallucinate parameters. The guided template constrains that rambling into a consistent, verifiable path.
Got it. Who's behind the work?
Led by Hai Dang with Meng Jiang at the University of Notre Dame, collaborating closely with a team at Amazon.
And what problem were they zeroing in on?
The everyday failures when agents use tools in the wild. Wrong tool choice, wrong arguments, misread user intent. Plus, the calls often appear as a black box, so when something breaks, it's hard to see why.
So they proposed the checklist. How did they get models to actually follow it?
2 tracks. First, plain prompting. Put the template in the prompt and have the model follow it. Second, fine-tuning so the behavior sticks. For that, they built a data set they call Tool GT. They start from a tool use corpus, convert multi-turn chats into focused single-turn tasks, ask a strong model to write the structured reasoning, and then verify the outputs with syntax checks and a second model acting as a judge.
Nice, so we're not just trusting the generator blindly.
Exactly. It's like having one model produce the step-by-step plan and another double-check that the plan really yields the right function call.
Where did they test this?
On 2 popular function calling benchmarks. One is the BFCL suite, which stresses functional correctness across categories. The other is Nexus, which mixes in tougher, more compositional tool use. They tried both prompting-only setups and fine-tuned versions across a mix of closed and open models. Think GPT-4 class systems and open families like Llama, Qwen, and Mistral.
And results-wise, what stands out without drowning us in numbers?
Big picture, the template usually wins. With prompting alone, models tended to beat both no-thought baselines and free-form chain of thought. A noteworthy wrinkle is that a smaller Mistral variant struggled to stick to the format when it was only prompted. But once they fine-tuned that model on the guided template data, it learned the structure and jumped past its earlier baselines.
So fine-tuning makes the checklist second nature.
Exactly. And there's another interesting case. One Qwen model had a very strong no-thought baseline for pure execution. Adding reasoning sometimes nicked that baseline on one benchmark, but the template was still more robust than free-form TOT and actually came out on top on the other benchmark. So the template tends to be a safer way to get interpretability without paying a big accuracy tax.
Speaking of interpretability, what do we get in practical terms?
You get a readable breadcrumb trail. Instead of a naked function call, you see why the model chose that tool, which parameters it extracted, and how it resolved types. If a call fails, you can spot where the thinking went sideways and fix the instruction or the tool docs.
That sounds good for debugging. Any ablation nuggets? Like, does a longer template always help?
Mostly, yes, but not always. The more detailed template often wins overall, but the paper shows cases where a simpler checklist was better for narrow subtasks, like deciding relevance. That hints at a future where the agent picks a light or heavy template based on the situation. Kind of like switching between a quick start card and the full manual.
Love that analogy. Now, every paper has caveats. What should listeners be cautious about?
A few things. First, the training data they use to build Tool GT doesn't deeply cover highly nested compositional tool chains. That showed up in some Nexus experiments where performance dipped on those gnarlier cases. Second, it's single-turn focused. Real agents often operate over multiple turns, and that's a different beast. Third, the interpretability claim is grounded in the visibility of the reasoning, but there isn't a human factors study measuring, say, how much faster developers debug with the template. And finally, because parts of the dataset are generated and judged by models, you always worry about subtle biases creeping in, even with verification.
So stronger coverage and more realistic interaction settings would help. Did they talk about multi-turn benchmarks?
They point to moving toward multi-turn evaluation next and expanding the data toward more compositional nested tasks, so the training matches the hard cases you see in the wild.
If I'm building an agent today, how would I use this?
Start small. Add a compact, readable checklist right before the function call. Things like identify the tool, read the doc string, extract parameters, convert types, and revalidate. Log that reasoning alongside the call so you can audit it. If you have the capacity to fine-tune, curate a little internal dataset in that structured format so your model learns the template rather than just seeing it once in the prompt.
And watch out for formatting brittleness in smaller models, right?
Exactly. Smaller models can be template shy at first. Fine-tuning or good instruction tuning data helps them form the habit. Also, measure latency and token cost. Structured reasoning adds text, and you'll want to keep the template tight.
Any quick example to make this concrete?
Sure. Imagine a travel agent bot. A user says, "Book me a hotel in Seattle next weekend near the conference center." The checklist makes the model first confirm the relevant booking function, scan the docs for required fields, extract city, dates, and proximity, convert next weekend into concrete dates, draft the call, and double-check that it passed a valid location and date range. Without that structure, the model might miss that next weekend spans a holiday, or it might pass the wrong parameter name.
That's a nice picture of why structure matters. Before we wrap, what's your one-sentence takeaway?
Give your tool-using model a small, explicit recipe to follow, and you get more reliable calls and a clear paper trail. Then, if you can, teach the habit with fine-tuning so it sticks.
And mine would be, structure beats vibes for function calling. But we still need better datasets and multi-turn trials to see how it holds up in the messiness of real systems.
Well put. That's our look at guided structured templates for function calling. If you enjoyed this, share the episode with a teammate who lives in API logs.
Thanks for listening to AI Podcast. See you next time.